Assalamu alaikum students. Today we will learn resistors in series and resistors in parallel. There is a rock concert in town and ticket cost just 90 rupees. So at the venue, the organizers were thinking about how they could collect the money from the people. There were 3 people allocated for collect the money. One of the members suggested that we can place the counters like this, and every person who wants to enter will pay $30 at each counter, so that the total will be 90. Another team member suggested that we could place the counters like this, and each counter will collect $90 from each person. Take a moment and think which counters will be faster. Without a doubt, it is the second case. The flow of people will be faster as there is no bottleneck. The first case offers more resistance. When resistors are placed like this in a circuit, we call it resistors in series. And when they are placed like this, we say resistors in parallel. The words say it all. The first resistors are connected in series, and in second case the resistors are in parallel. Just like the flow is restricted for people here, the overall resistance is higher when they are connected in a series. And because the resistance is higher, the current flowing will be lower. And like our concert example, the overall resistance is lower when resistors are connected in parallel. Why this happens? What is the idea behind it? Let me explain to you. We have seen the two methods of putting system of resistors in the circuit. First in series like this, and second in parallel like this. The circuit which we have seen consists of only one battery and one load resistance is very simple to understand, but they are not often found in practical applications. Most of the time we find circuits with 2 or more components connected together. If you want to see the resistors in circuit, they would look like this. These 3 resistors are in series and these 3 resistors are in parallel. Let's see some practical examples. Take this circuit for example, in which one bulb is acting like a resistance. Once the circuit is complete, you will see that the light glows brightly. Now let's add another bulb in the series and see what happens. We close the circuit and notice that brightness of each bulb has reduced, and if we add one more bulb, the brightness will reduce even more. What does it imply logically? Tells us as we add more bulbs or resistors, the current in the circuit decreases. Overall resistance in the circuit is increasing. This was the conclusion for resistors connected in series. Overall resistance increases and the current in the circuit reduces. What will happen in parallel resistors? We take a normal circuit like this, consists of one light bulb. But before we started connecting more bulbs in the circuit, we connect a test bulb in series here. The test bulb will give us the indication that how the current is changing when we connect more bulbs in the parallel. So at this moment, some current is flowing through this circuit. Now we add a light bulb in parallel. What did you notice about the brightness of the test bulb? It has increased. That's right. After we add another bulb in the parallel, we will see the bulb will glow in a brighter fashion. The overall current increases as we add more resistors in parallel, which means overall resistance in the circuit decreases. So this is the difference between resistors connected in parallel and in series. We have 3 resistors of different values connected in a series. How do we know they are connected in series? Because they are connected one after another and they are using only one path, not the multiple paths. Now we will perform a small activity. Close the plug key and note the ammeter reading with these 3 resistors connected in series. Let it be IM pairs Next, place the ammeter somewhere between resistor R1 and R2. Similarly, between R2 and R3 and note the reading. What will you notice? That the current will be I amperes in each case. Yes, the current is constant at every point in the circuit. It tells us that in series combination of resistors, the current flowing is the same throughout. Okay, let's remove the ammeter which are between the resistors and try out something else. Now insert the voltmeter at start of the first resistor and at the end of third resistor. Now plug the key and note the potential difference across the resistor. Let's say it's V volts. Now take out the plug and disconnect the voltmeter. Now add 3 voltmeters in the circuit like this, one across each of the resistors. Now plug the key and measure the potential difference across each of the resistors. You will notice that the potential difference across each of the resistors, let's call them V1, V2 and V3 respectively. Even though the voltages are different, you will notice that the potential difference V will be equal to the sum of the potential differences V1 plus V2 plus V3. This helps us derive something very important. Let's look at this circuit again. The potential difference is V volts and the current flowing through it is I amperes. Let's say that these resistors together form the resistance R ohms. We still don't know what R is, but we just assumed all the 3 resistors combined together will give us the total amount of resistance in this circuit. According to Ohm's law, we can say that the V is equals to IR. This was the entire circuit. Will you try applying the Ohm's law to each of the resistors separately? It's easy. For the first resistors, the potential difference is V1 volts. The current flowing through it is I amperes and the value of resistance is R ohms. Applying the Ohm's law for the first resistor, we get V1 is equals to IR1. Similarly, for the other 2 resistors, we apply Ohm's law to get more equations. Now we can substitute the values of V1, V2, V3 in the first equation to get the result we need. V is I times R, V1 is I times R1, V2 is I times R2 and V3 is I times R3. Dividing both the sides by R, we get the value like this. So what we have got? Resistors are connected in series. The overall combined resistance R is the sum of the individual resistance. Now you understand why the resistance increases when they are connected in series, because each resistor when added in series will add up to the previous resistance.